So let us now discuss problem number 1. A rectangular, simply supported, reinforced concrete beam has a cross-section of 250 mm by 510 mm and a simple span of 6 meter. So meron daw tayong simply supported beam na merong length na 6 meter. Tapos yung width daw ng beam natin is 250 mm by 510 mm. So usually sa mga problems natin, inuuna lagi yung base, tapos yung height ng beam natin. So the height of our beam, that is 510 mm. It is reinforced with 4 20 mm diameter bars in one row. So in a single row, meron tayong 4 na piraso ng 20 mm diameter bars. The center of bars being 60 mm above the bottom of the beam. So yung sentro daw ng bars natin from the bottom, that is 60 mm. So from the center to the bottom of the beam, we have a distance of 60 mm. So meaning to say, yung effective distance natin from the top of your beam to the center of your reinforcement, that is 510 minus 60, which is equal to 450 mm. So using Fs is equals to 124 megapascal. So we have yung Fs natin na 124 megapascal. Fc, which is equal to 7 megapascal. The modular ratio, which is equal to 12. Determine the additional P that could carried by this section at midspan besides a uniform load of 12 kN/meter, including the weight of the beam. So dito sa 12 kN/meter natin, already included na yung bigat ng beam natin. And dun sa problem natin, wala naman tayong given na unit weight ng concrete. That's why ine-neglect natin yung bigat ng konkreto natin. So for this problem, sa 12 kN/meter, included na agad yung bigat ng biga natin. So for this problem, we are tasked to find the value of your P. So ano yung magiging value ng P natin? So, yung general procedure lang naman natin dito is kukunin natin yung mga allowables natin. So, kukunin natin yung mga allowables natin sa flexure, sa shear, at saka sa bond stress. So, from that, kukunin natin yung pinaka-safe na value ng P natin. So, unang-una dito is, let us consider flexure muna. So, in considering flexure, kailangan muna nating malaman yung mga beam constants natin. So sir, ano po yung mga beam constants na to? So kung natatandaan ninyo, referring to beam constants, ito yung mga kinakailangan natin para malaman natin yung value ng resisting moment natin sa concrete at saka yung resisting moment natin sa steel. So, unahin muna natin sa beam constant natin is yung value ng steel ratio natin, which is equal to area ng bakal all over yung BD natin, yung width at saka yung effective depth. So, as discussed on the previous discussion, kapag sinabi natin steel ratio, ito yung ratio ng bakal versus dun sa effective area ng concrete natin. So, as I've stated, diba, yung 60 mm na to, it will only serve as yung magiging covering lang ng steel reinforcement natin against rusting. So, yung inias natin, meron tayong 4 na piraso, bakal. So, kunin natin yung area niya. So, that will be pi over 4. So, meron tayong 20 mm squared all over yung base natin, which is equal to 250 mm, yung effective depth, which is equal to 450 mm. So you have a seal ratio which is equal to 0.0117. Then, meron tayong value ng modular ratio natin which is equal to 12. Next, so kunin naman natin yung value ng K natin. So using yung formula natin dealing with seal ratio at saka yung modular ratio, makukuha natin yung value ng K natin. So, K is equals to square root of 2 rho n plus rho n quantity squared minus rho n. So, for this, isa-substitute lang natin yung mga values natin for rho at saka yung n. So, dito yung value ng rho natin. So, yung value ng rho natin, that is equal to 0.01117. And yung value naman ng n natin, that is 12. So, usually given naman yung n natin. So, that is 12. So, K is now equal to 0.4008. Next naman, after computing for the value of your K, makukuha na ngayon natin yung value ng J natin, which is equal to 1 minus K over 3. So we have a value of 1 minus 0.4008 over 3. So you have a value of 0.866. Sir, bakit po natin kinompute yung mga values ng beam constant natin? So, as a form of review, para makuha natin yung resisting moment natin sa concrete, so that is equal to C multiplied by JD. So, ano ngayon yung formula natin for C? So, that is 1/2 multiplied by FC multiplied by K multiplied by B. So usually, ito yung formula natin sa pagkuha natin sa C. And lalagay natin yung so meron pa tayo ditong D, tama? 1/2 FCKBD. So JD, and then is-squared na natin. So that is the formula in computing for the value of your resisting moment sa concrete. So isa-substitute natin yung mga values natin, yung FC natin. So yung FC natin, we have a value of 7. So this is 7. Yung K naman, this is equal to 0.4008. Yung J naman yung B naman natin, that is 250. Yun yung width ng beam natin. Yung J, that is equal to 0.866. And yung effective depth naman natin na naka-squared, that is 450 naman. So, kung i-compute natin yan, so you will have a value of your resisting moment in concrete, which is equal to 61.5 times 10 raised to 6 Newton mm. So, kung i-convert mo yan, yung Newton mm natin into kilonewton mm, all we need to do is alisin lang natin yung times 10 raised to 6 and magiging kilonewton mm na yan. kilonewton meter pala. Next, kunin naman natin yung value ng resisting moment natin sa steel. So sir, paano po natin kukunin yon? So that is TJD. So yung formula natin for that is TJD. So resisting moment in steel. So that is TJD. So yung formula natin sa T, that is AS FS JD. So, compute lang natin ulit. So, yung area ng steel natin, that is pi over 4 multiplied by 20 squared. So, meron tayong 4 na piraso. Yung value ng Fs natin, which is given, which is equal to 124. Yung J natin, which is equal to 0.866. And finally, yung value ng D natin, which is equal to 415 mm. So you have a value of your resisting moment in steel, which is equal to 60.724 times 10 raised to 6 Newton mm. Kaso nga lang, para ma-convert natin yung Newton mm to kilonewton meter, aalisin lang natin yung times 10 raised to 6. So we have a value of 60.724 kilonewton meter. So ngayon we have yung dalawang values ng mga moments natin. First sa concrete, which is equal to 61.5, and sa steel naman, which is equal to 60.724. Ngayon yung tanong dito is, ano yung i-adapt natin sa dalawa? So what is our safe value of your moment? So sa mga loadings natin, always remember, yung always na ina-adapt natin is yung mas mababa, which is equal to 60.724 kilonewton meter. Sir, bakit po mababa yung in-adapt natin? Kasi nga, yung example, eto sa concrete natin, hanggang 61.50 yung kaya niya. So meaning to say, kaya niyang dalhin yung 60.724. So yung konkreto natin, hindi siya masisira either na ito yung apply natin o yung sa moment sa steel. On the other hand, hanggang 60.724 lang yung maximum capacity ng steel natin. So kung ipapabuhat natin kay steel, yung moment natin sa concrete, masisira lang si steel. That's why i-adapt natin yung lower value. So we have a resisting moment which is equal to 60.724 kilonewton meter. And for that, hanapin na ngayon natin yung value ng P natin. So let us consider first yung flexure natin. So dealing with flexure, kino-consider lang naman natin dito is yung moment natin. So for this, since meron kunin natin yung maximum moment, since we have a uniformly distributed at saka concentrated load acting at midspan, so by formula, we can solve for the value of your P. So ano yung maximum moment natin sa uniformly distributed load? So that is WL squared over 8 plus, kapag naman acting at midspan, yung load natin by superposition method, idadagdag lang natin yung concentrated load natin acting at midspan, that is PL over 4. So yung W natin dito ha, yung weight ng beam natin, it is already included. So substitute lang natin yung mga values natin. So we have a value of your W na 12 kilonewton meter. Yung L naman natin, that is 6 na naka-squared. So yung L natin dito, that is 6. So yung Mmax natin dito is i-equate lang natin to the value ng safe moment na nakuha natin between the resisting moment ng concrete at saka yung resisting moment ng steel. which is equal to 60.724 kilonewton meter. So by shift solve, we can now calculate for the value of your P, which is equal to 4.483 kilonewton. Or let's say, that is equal to 4.5 kilonewton. So, against flexure, meron na tayong nakuha ditong value. Ngayon, i-consider naman natin yung shear natin. So, after considering the flexure, let us consider naman yung shear natin. So, tatlo yung i-consider natin dito. Una, flexure. Pangalawa is sa shear. Pangatlo is yung sa bond stress natin. So, consider muna natin yung shear. So, sa pagkuha sa shear natin, kailangan natin munang kunin yung allowable natin. O yung V allowable. O yung allowable shear stress natin. So, yung allowable shear stress natin, that is equal to 0.09 square root of F prime C. So, since hindi naman given yung F prime C natin, kailangan muna nating makuha yung value ng F prime C. Eh, yung given lang natin, that is, FC lang, which is equal to 7 megapascal. So, yung formula natin, para makuha natin yung F prime C is 0.09. So, yung FC natin, i-divide lang natin yan by 0.45. So, yung FC natin, that is equal to 7. So, palitan lang natin to ng 7 megapascal. So, you have a value of your V allowable, which is now equal to 0.355 megapascal or Newton per mm squared. Ngayon naman, meron tayong V allowable. Kailangan nating makuha yung value ng V actual natin. So, V actual, that is equal to yung shear distance na, shear at distance D natin over yung area natin, which is equal to B multiplied by D. So, sir, paano po natin kukunin? Kasi, meron na tayong value ng B, which is the width of your beam. Yung D naman, that is the effective depth of the beam. Sir, paano po natin kukunin yung V sub D? So, yung V sub D natin, that is yung shear at distance D from support. So, kukunin daw natin yung D, yung VD natin, yung shear at distance D from support. So, from the support, eto yan. So, meron tayong 6 meter. So, from the support daw, kunin natin yung shear at distance D. Eh, yung D natin, yung effective depth. So, eto yung effective depth natin. So, kunin daw natin yung shear natin dyan. So, this is 0.45 mm. So, hahanapin natin yung shear at 0.45 meter from the support. So, paano po natin malalaman yan? Hahanapin natin yung shear dito. Paano natin hahanapin yan? So, we can use shear and moment diagram or we can cut a section. So, let's say mag-cut na lang tayo ng section. So, dito nyan. So, yung support natin dito, we have. So, yung mga reactions natin dito. So, meron tayo dito na yung 12 kilonewton meter. So, yung uniform distributed load natin. Paghahatiin ng dalawang support. So, that is WL over 2 plus. Ito namang concentrated load natin acting at midspan. Paghahatian ng dalawang support, which is P over 2. Tapos dito, P over 2 din. So, ito nyan, kung isi-simplify natin yan, you have 12 multiplied by 6 divided by 2, you have 36 plus P over 2. So, kung i-consider natin yung nakat na section, so let us consider yung nakat na section. So, you have, ito yan. So, consider natin yan. Ito yung nakat na section natin. So, lilitaw dito yung support natin na 36 plus P over 2. Tapos, yung uniformly distributed load natin na 12 kN meter. So, meron tayo dito uniformly distributed na 12 kN per meter. Tapos, yung distance niya, that is 0.45 meter. So, ngayon, yung tanong dito is, what is the value ng VD natin? So, yung value ng VD natin, since we're going to consider yung left segment, so that is equal to, so kapag left segment, upward positive, downward negative kapag left segment. So, dito nyan, we have 36 plus P over 2, kasi nga upward, etong reaction natin, minus etong downward natin, yung uniformly distributed load, which is equal to 12 multiplied by 0.45. Okay. So the value of your VD is now equal to 30.6 plus P over 2. So ngayon, may value na tayo ng shear natin at D. Diba? Ng shear at distance D from the support. Makukuha na ngayon natin yung value ng V actual natin. Kaso nga lang, para makuha natin yung value ng P natin, yung gagawin natin is V allowable, i-equate natin sa V actual. Wherein yung V actual natin, so that is equal to yung VD natin na 30.6 plus P over 2 over yung B natin o yung width na 250 multiplied by the effective depth na 450 mm. So with this, gagawin natin is i-equate lang natin sila. Yung V allowable natin, which is equal to 0.355 Newton per mm squared. So, eto nyan, yung 250, naka-mm to, yung effective depth, naka-mm, so, naka-mm squared tayo dito. How about, dito naman sa taas? So, dito naman, yung unit natin dito, kilonewton tayo. So, para makapag-shift solve tayo ng maayos, i-convert natin etong newton na to into kilonewton. So, in every 1,000 newton, meron tayong 1 kilonewton. So, with that, by shift solve, makukuha na ngayon natin yung value ng P natin, which is equal to, P is equal to 18.675 kilonewton. So, meron na tayong dalawang value ng P na nakuha natin. So, una, considering the flexure, we have 4.5. Next, considering the shear, we have 18.675. So, lastly, we will going to consider naman yung bond stress natin. So, yung mga allowable values natin dito, written yan sa modules natin. So, bond stress ngayon, yung i-consider natin. And siyempre, by general rule, after natin makuha yung value ng concentrated load na P dun sa bond stress natin, we will going to compare yung obtained value natin to the value ng 18.675 and the value of 4.5 kilonewton. Now, considering bond stress naman, So, paano natin kukunin? Yung allowable band stress muna natin. Or yung U allowable. So, nasa module natin na yan. So, ano lang yan? By formula, which is equal to, so that is only equal to 10.14 square root of F prime C over D. So, dito nyan, we have 10.14. So, yung F prime C natin, so that is FC over 0.45. And then, yung D natin, o yung diameter ng bakal natin, which is equal to 20. So, yung F sub C natin dito, that is 7. So, so the value of your allowable band stress, that is equal to 2 megapascal. Next, nakuha na ngayon natin yung allowable. So, same dito sa shear, kukunin naman natin yung actual band stress natin. O yung tinatawag natin U actual. So, yung U actual natin, that is Vmax over yung epsilon O multiplied by JD. So, yung Vmax natin, kukunin lang natin yung maximum shear natin dito. And yung epsilon O naman natin, that is the sum of bar circumference. So, usually kapag band stress kasi nangyayari is nalilipat yung stress natin from the concrete to the circumference ng mga steel bars natin. So, meaning to say, along this circumference, eto yung dito, nagtatravel yung stress natin. Eto yung tinatawag nating epsilon O. So, meron tayong 4 na bakal. So, with this, yung J natin, yun yung na-compute natin kanina. Yung D naman, that is our effective depth. So, same principle lang tayo dito. So, yung allowable natin, yung U allowable or the band stress allowable, i-equate lang natin siya dun sa actual, which is equal to yung Vmax natin dito. So, that is 36 plus P over 2. So, usually, kapag ano lang naman, yung maximum shear natin, that is yung reaction natin sa support kapag simply supported. Tapos, uniformly distributed, pati, concentrated load acting at midspan. Over, yung epsilon O natin, so for 4 na piraso. So, hanapin natin yung circumference, that is pi D. So, pi multiplied by 20, multiplied by J na 0.866, and then yung D natin, which is equal to 450 mm. So, kung titingnan natin dito, so yung value ng U allowable natin, that is 2 megapascal or 2 Newton per mm squared. Ito namang sa taas natin dito, that is in kilonewton. Ito, naka-mm to, naka-mm yun. So, naka-mm squared tayo. So, yung problema lang natin dito, hindi uniform yung mga units natin. So, dito nyan. So, in every 1,000 Newton, meron kang 1 kilonewton. So, magiging kilonewton niya per mm squared yung U allowable natin. So, by shift solve, makukuha na ngayon natin yung value ng P natin. So, P is now equal to 319.77 kilonewton. So, meron na tayong tatlong value ng P. So, we have 4.5, 18.675, at saka 319.77. So, therefore, i-adapt natin yung smallest value. Adapt P is equals to 4.5 kilonewton. So, this will now become our answer. So, ganun lang yung methods of procedures natin in computing for the value of your P.